Welcome to Talking Tuesday. I am your host, Fancy Quant, and today we are going to talk about the defense of basically the scientific system here, right? So I feel like this is really sad. I have to come out and say this, and yet we continually see this throughout all industries. I get this question a lot, so let me phrase what I'm talking about here. I will have questions like, Dimitri, clearly econometrics is a joke and a stupid field, and it makes no sense. So it's wrong. So you shouldn't be recommending books on econometrics. And then I have other people saying, okay, financial engineering is dead, stochastic calculus is dumb, it doesn't make any sense, there are much better ways to do it. We just throw that out the window. And then I have other books, so yes, books written by industry practitioners, academics as well, and they come out and say, Dimitri, statistics is outdated, it's boring, it doesn't work very well. We're going to replace the entire system of statistics with data science and machine learning. And I just scratched my head because some of you say this and it's like, I get it. You're a student, you have no idea what's going on. Your view of the world is so very narrow that you don't see the full spectrum. So I give you the benefit of the doubt of, okay, I'll try to explain this to them. I try to make this a more well-rounded view and perspective. And you understand how the world gets put together, and you understand the scientific method here, which is kind of what is being attacked, but people don't fully understand that. And then I go to books, and I'm not going to say which books, but there are authors out there that are very, very well known, and they go into say data science, machine learning as a very hot topic right now, and they trash statistics as like this big waste of time, and it's dumb, and it doesn't work, and they go on and on and on and on. And it's so outdated because it's so old, it's prehistoric, we're using these outdated methods, and it makes no sense. And these people I look at and I go, well, you basically just aren't very mature academically. And it starts to make me question almost your entire academic career because, again, you're missing the crucial aspect of how the world actually functions and how it actually works. And so then it's this frustration thing of like trying to figure out how do you explain this to people in a simple way that is cohesive, but also covers everything under the sun. And I think the easiest way to explain this is the scientific method. So what is the scientific method? Let's just dive in here quickly. The scientific method is basically we're going to use logic and we're going to use a bunch of different tools based off of logic to try to come up with a conclusion of how the real world works. So this has been used, this is, I guess, the scientific revolution or whatever you want to call it, where we started using actual science and rigor to analyze problems, and this actually discovered basically everything we know of. So you can think of things like medicine, you can think of things like physics, for example, like understanding how gravity works. These sorts of things, again, all derived from a scientific method. And what this means is that you can no longer just come out and make some sort of statement like, I think the world is flat, and then everybody just agrees with it because who you are, which seems to be how our modern complaint system of people that are criticizing this method here without realizing it is working. They're coming out and saying the world is flat and that's just how it is. There's no analytical rigor to do this. And so the tools you're going to need on this is going to be logic. So yes, logic is not just me saying, oh, it's logical. There's a whole field of studies on logic and you can actually take classes on it in college. And when you start layering and building onto these different fields, we start realizing we need mathematics. So you need, for example, like probability theory, you need statistics. Again, you're going to need all sorts of models and things to support your view. And then we get into sampling. So how do you repeat an experiment over and over again to see if it works consistently or if there are deviations from it? Why are there deviations from it, right? This is the scientific method. We are trying to use science to actually come to conclusions on problems we have in the world, okay? This is extremely important for academics. So going into a little bit of academics here, it doesn't matter which field you're in. When you typically go and you create some sort of hypothesis, you state some statement first. So let's say the world is flat, right? And you make this ridiculous statement up front. Often you think it is true, you're not fully sure, and then you need to create an experiment to test this. So you go out and gather data from this, and then you take samples of this. So the world is flat is kind of a hard thing because I'm not an expert on, physics and all that here. But let's say you have, some sort of new drug test that you're going to do here. So you go out and you say, okay, I have this new drug. I'm not sure if it really works. If it doesn't really work, we know there's something called the placebo effect. So when people think they're taking something that is beneficial, they often feel better. And so you end up going and getting a bunch of people. You try to get some representative sample based on age, gender, ethnicity, and a bunch of different factors that you think might control for variances in the experiment and how the drug actually works and functions. And then, of course, you come back and you get all these samples and you put part of the people on the placebo. So you give them a pill that looks the exact same as everybody else's in this example. And then you give the other group, right, the actual medicine in the same sort of pill. So the one's going to be sugar, the other one's going to be actual medicine. And you actually use statistics to see if there's a significant difference between the two. Okay, so this is just the core of science and how we discover things and work on things. Now, it should be noted here as well across time that often we come to some conclusion based on some experiment, based on the information we have, and we come to say, okay, this is how things are. And then as more information comes out, more data comes out, or even like in modern times, as computing power becomes better and better and better, more complex experiments can be designed, more complexities can be added into these sort of experiments, and we can get different conclusions, and often many of these theories get overwritten over time. So, I mean, there's different ways of looking at this, but basically we have advances, we have more information, maybe somebody made a mistake, and it's important to understand too in the academic community that often an experiment will be reconducted by multiple different groups in essence to support it or deny it. So say I'm a professor and I can create this medical experiment and I run it and I come to the conclusion the medicine works. Then another group of scientists, so say, I don't know, we'll call her Mary. Mary is another scientist and she has a team of people at a different university or a different, drug institute or whatnot. And they actually go out and they'll rerun the experiment again, but they do the same experiment with the same guidelines, but now they're going to sample different people, right? They're not going to go back to my same people. So they're taking another sample and then they go through this process of trying to figure out if it works or not. So why does this matter? How does this tie into econometrics, data science, quantitative finance, machine learning, and all this? Well, it comes down to kind of the core here. So first of all, every single study, if done by the scientific method, should be a valid study. Okay, so it doesn't matter what you're studying. It doesn't matter if you're studying, like economics typically focuses on the economy, but it looks at it more so from a level of individual decisions, both from individuals, corporations, and government, and how these interact and how these impact businesses and financials and people's well-being. Again, finance is really a subset of economics. Again, you can deviate them out and try to distinguish them a little bit differently. It is what it is here. But that's economics. And one of the reasons I get the economics comment, so I'll touch on this briefly, is that a lot of economics is really hard to test. So we can't scientifically test a lot of our theories because it is viewed as, and I would agree with, it is unethical in many scenarios. So, I don't know, let's say we are going to take a group of people and we're going to test, like unemployment rates and how much money you make or something. So let's say we go in and say, okay, we're going to cap out a bunch of individuals at a specific level of income, and we're going to let a bunch of other individuals make as much money as possible. So basically what we're testing here is that having some sort of universal income where everybody makes the same and everybody's extremely equal in one sample, and you're going to have another sample, which is capitalism, and we're going to test the fact that these individuals can make almost nothing or they can make infinite amounts of money. And we're going to do this over someone's lifetime here. And then we're going to see what comes out at the other end. Well, this is really unethical. And so people don't like to do these sorts of experiments. So let's say, for example, capitalism wins out, which is what would happen. Again, I'm not going to argue in the comments about this, but capitalism, you'd see people that would actually do very poorly because some people just didn't want to work that hard, or they didn't have the right skills, or they didn't choose the right career, or there's all these factors that play into this. And then you have other people that did extremely well. On the other hand, you're going to have, so in this case, right, it's unethical because people don't like that maybe these poor people had a bad shake, right? They had this poor life. They didn't put in the effort required for this sort of system. And so therefore they lived a terrible life and are poor and maybe had, unhappiness and all these other issues. Now, on the other side, if you have the socialism model here we're trying to model, and you show that everybody gets paid the exact same no matter what job they do, you might say, okay, well, those individuals that are really poor in the capitalist experiment now out there in the socialist experiment would do extremely well. They'd be the same as everybody else. They would obviously be happy and the world would be great and rosy. But then they start to realize there are other differences between the two systems, and you start realizing, for example, right, the economic growth of the entire group as a whole in socialism didn't work as well as capitalism. But as you start going through these, right, people don't want to be forced into these sorts of experiments because it alters your entire life, right? It's not a very ethical standpoint. So we can't do that. So I can't go out and find people and put them in these like bubble chambers of experiments and do things with them. It's just not an ethical way of doing this. So what we typically resort to is we say, okay, we're going to compare countries. But the issue, again, with economics is there's so many complexities and differences between countries, both in the policy and the laws and the amount of government that each country has, to the types of work, the type of success that you see in different countries, the way that income distribution occurs. There's all these really nuanced things, and it's easy to say, okay, I'm going to compare, this country, which I view as capitalist, and this country as socialist. But often we start seeing bleeding across this as a spectrum, and then you have communist capital systems you have to incorporate in this. And so it's extremely hard to tease these out. Also, again, we don't have a hard science for this. So I can argue and I can make my points on capitalism and why it's so beneficial and why it is great and wonderful. And of course, there's going to be people that don't benefit from the system, which is a whole other issue on this. But again, it's hard for people to agree on this, and there are other countries that do things differently, and so economics is not a hard science. So it's really hard to set experiments and to use the scientific method to come to a conclusion. Now, back in the day, and this is kind of a residual here, economists get really excited and they use econometrics. What is econometrics? Statistics applied to economics. You take economic theory, you support it with statistics. I think it's really odd it has its own name and its own field, because as I mentioned, right, every single study, whether it's, sciences like biology or psychology or something else, they're all going to use statistics to come to conclusions using the scientific method. But the problem you have in economics is there's an entire grouping of people, which again go against my belief systems and how I view how the economy works, for example, in economics. They have this goal that government needs to get involved and they need to control your lives. And the Federal Reserve and all these economic schools are going to train people to learn how the economy works. And we're going to teach them how to manipulate the economy to get what we want out of it. Okay. This is, I think, complete nonsense. You should not be controlling and manipulating and stuff. Your outcomes are always worse than letting an actual free market handle it. But when you train people this way, it loses a lot of validity. And then you have a lot of critics, both on the economic side, such as myself. You have people in the industry, you have people outside of the industry, you have other academics in other fields, all criticizing now that you're using models and statistics inside of econometrics in inappropriate ways. And I would agree with this. So they're not following the scientific method. They're trying to basically make the shoe fit to make an argument. Now, this abuse of the system has kind of diminished economics because we don't come to a clear conclusion between all the groups. There's a lot of contention between it. And now those using statistics on the econometric side have often abused these tools in a way of chasing correlations without looking at causality in dynamic structures. And so trying to put all the pieces together has been very challenging. And this has kind of diminished the name of economics. And again, you have kind of two camps here. You have pure theorists, they specialize in the theory here, and they're not using any science, so they're not using the scientific method. And then you have econometricians on the econometric side, and they are actually abusing science and statistics in ways that it was not meant or intended to use, and they're breaking a lot of violations in the statistical realm and the theoretical realm of economics to come up with ridiculous, absurd conclusions. And because of this, economics has lost a ton of respectability in most areas and most fields. So I don't think economics is wrong. I don't think econometrics is wrong. They're just bad players involved in this industry. Now, quant finance is coming into light. You see similar things probably after the econometric boom here. Quant finance, again, you see a bunch of people that have dove in here from all these different academic fields, physics and biology and chemistry and mathematics and, stats and all this. And they all come together and they build all these models, and a lot of them don't fully understand what's going on. Again, these statistical models, the scientific method being used that underlies all this analysis, is being abused to the point that it didn't make any sense. We're just chasing dollars. We're trying to maximize correlations, and we throw theory out the window and no longer look at what's actually causing these sorts of things. So again, financial engineering, it looked like it was a really good promise. There's a lot of abuse of the system. It was paying a lot of money, so not everybody's pouring in. Everybody's saying, hey, look at me. I'm a quant. I want to make a bunch of money. And then again, a lot of these people claiming to be quants, aren't quants academically. They don't even have the education for this. They're not even at the level they should be. And now they're making incompetent decisions and making the industry look bad. And then on top of that, so they go out and write papers, for example. I'll give you an example here. They write all these papers and they write all these online forums. They talk about trading and making money, and they're real quants, and yet they're not following the scientific method. And so again, they're not really academics. They're not really quants per se. And so now you're tarnishing quant finance and it looks like a really terrible, crappy industry. And so now it's like, no one wants to be a quant anymore because now you have all these people that are non-quants saying they're quants, but they just suck at doing their jobs and don't know what they're doing. And now we kind of roll forward to a lot of my criticisms. So a lot of people think, Dimitri, you seem very anti-data science and very anti-machine learning, which is very, very far from the truth. But it comes back into this criticism. So I don't think data science is dumb. I don't think it is inaccurate. I don't think it's wrong or misleading with data science and machine learning. I just think this is now the new econometrics or the new quant finance. This is the new wave and trend where everybody's diving in. So you can search online. You can find, I don't know, forums and stuff like towards science or towards data science and like, I don't know, Kaggle competitions and all this nonsense. But again, you're having a ton of people who are not qualified, who don't have the education, who don't understand the scientific method, coming in, abusing the policies, abusing the methodologies here, not using them correctly, violating assumptions and usages. And yes, there are assumptions in data science. There are assumptions in everything you do. Now, this is part of the scientific method, right? We don't know things for a fact, so we have to draw conclusions and depend on statistical analysis to do this. This applies to data science and machine learning. And again, I am extremely critical of data science because there are so many incompetent people in the industry. Now, again, this comes back to this issue. I don't think data science as a field of study here is wrong. I don't think it is incorrect. Now, you can take these tools and you can abuse them and apply them to incorrect problems. Or you can ignore the weaknesses of these and kind of sweep it under the rug and build all kinds of tools that don't work very well and fail miserably. And again, so data science is one of their big criticisms. They overfit everything. As you kind of listen to this podcast, right, what have I been talking about? The problem with econometrics and quant finance has been everybody gets really excited about correlations, but they ignore causality. So they're going to be overfitting without regard to robustness of their models. Again, this keeps coming back to this, but data science and machine learning has very, very specific applications that are clear winners here where it's done amazing. Image processing or image recognition, and then neural networks used with like natural language processing. So image recognition, neural networks. NLP though, as a field in itself, using NLP has been quite interesting and amazing as well. These are things we can't do with statistical models because of how they're based. But again, we go back to the core here, right? Why would you say statistics is dumb and stupid and doesn't work? And yet data science is really a subset of statistics. It still applies to a lot of these methodologies. People go, well, there's no assumptions. Well, logistic regression doesn't have any assumptions. And that's still statistics. So why would you think that they're different? And people start arguing, well, logistic regression is really a part of data science. Well, it was actually part of statistics beforehand. And so you have these arguments and debates. But I think what we come back to here is looking at the people that are abusing the systems and not using them correctly is the problem. I have no issue with criticizing that or even challenging hypothesis and testing methodologies, given you go after them in a scientific method here. The issue I have, so in conclusion of this, is you shouldn't go out there and say this field is dumb or this field doesn't work or this field is nonsense or this stuff is outdated, because the reality is they're all tools that we continually use, okay? You can come up with things that we thought in the past that were wrong and we can iterate on them and correct them. But everything is dependent on statistics, math, computer science, in the data science, machine learning, quant finance realm here, right? We're all using the same set of tools here. Again, data science, machine learning and all that, and AI has added new layers of methodologies based on computer scientists' approach to actually come at statistics. But again, we're all kind of moving towards that same thing here. Now, to point out, I think, on a lot of the complaints and my frustrations with the professionals that are out espousing these sorts of things, I think often they are looking at it from a couple perspectives. One, just a lack of maturity, I think, in a lot of ways here. So they will go out and bash that these methods are outdated, they don't work, and they go on and on and on and on about all these horrible things about them. And yet when I go back and look and I say, which firms are you criticizing? And they say, oh, this massive hedge fund and this one and this one and this one. Okay, great. I said, well, I've actually met people from these funds and they didn't do their job right. And here's the examples of how they didn't do it. And they go, oh. And I've also read their books that they've written, and their books are actually incorrect and wrong. So they don't even understand the basic stats they were using to build statistical models. So your stats models didn't work because they didn't do it right. And then they'll go, oh, no, it doesn't work. The theory doesn't work, and they'll try to argue it. So there's one of the lack of maturity, I think, on some of these professionals. The second piece is a lot of them are actually doing the same thing I'm doing, criticizing these industries, criticizing these firms, criticizing these fields of study. But again, you have to be very careful, and I try to be as careful as possible here as well. I'm not criticizing the study per se and the science. I'm criticizing the people that are actually doing it. And I think there's a big distinction between that, because as long as things are done with the scientific method, it has validity. If you're just criticizing a method, but it's actually statistically, mathematically, and logically backed here using the scientific method, there's nothing wrong with that. The issue comes when people start to abuse these systems. So I was somewhat of a critic on the Black Swan book as well. And yet I think it was an extremely challenging book to write. The criticism, the point of views, the perspectives and everything. I have a bunch of issues with the book, but I understand and agree where, Nissim Taleb is coming from with this, where, again, these models were abused statistically. Copium models, for example, were very abused. The normal distribution was overly dependent on, and then you start going back to why this occurred, often because things get too complex. And so instead of getting into complex mathematics and stats, the scientific method here, we just choose to make a bunch of assumptions to go something very easy, which is the normal distribution in finance. And again, it typically doesn't hold. So I agree. I support a lot of these individuals as well and what they're trying to do, the angles they're coming from. But sometimes I don't think the way they go about it is the best. And I think they need to be very careful, which I'm trying to do myself, at how do you approach this while explaining, like, data science, for example, is currently in my target, my radar here. The field is great. There's good applications, and appropriate testing and research needs to be done. But again, the vast majority of people doing it are incompetent and don't know what's going on here. So again, picking where you're criticizing and how you're doing it, but also being careful that you are correct and that you can point out issues and mistakes with that as well. So those are my 2 cents here, I guess, on the scientific method. These are my 2 cents on, is econometrics a sham? Is economics a sham? Is data science a sham? Is, machine learning and all that? Like, everyone thinks these things are kind of like these fraudulent fields of study. And often we kind of go back and look at things from a pure academic perspective, and it's fine. And yet when we look at applications and publications and things like that, often there's just a lot of fluff being generated because people don't know what they're doing. So anyways, thank you for listening. Thank you for watching. And as always, until next time.